Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad you're with us today to stay curious. Today, we're going to the moon with the wonderful science experiments with this gentleman, Mr. Keith Wright. Hi, Keith.
Hi.
Keith is one of the British Apollo engineers who walked into our museum yesterday and met him for the first time. And he started telling me his story about working on the Apollo Lunar Science Experiment packages.
That's
So
correct.
we corralled him in to stay curious, and we loaded up a bunch of pictures, some I've never seen before, that Keith had to tell his story of working on this ALSEP program there. How are you? You and your wife are visiting the States?
Yeah, we're visiting friends that we made when we were living here working on Apollo. We've known them for, 57
Is
years.
that right? Where'd
Yeah.
you grow up? And
I grew up in Nottingham, Robin Hood territory.
yes,
in England.
indeed. All right.
And,
Sherwood Forest. And
yeah.
all.
I went to
Is there a
school.
real Sherwood Forest in
There is,
Nottingham?
there still is.
Okay,
It's
all
a
right.
lot smaller than it was, but there still is one. And I went to university there, to Nottingham University, and studied physics. And when I left university, I was interested in space. I'd been interested in space since I was a kid.
Uh-huh.
And what I did, I looked around and I found that there was a company that was working on our British ballistic missile, which was a derated version of the American Atlas. So I wrote to them. I had a bit of knowledge about rockets at that time because I'd been a member of the British Interplanetary Society.
Okay.
Funnily enough, one of their magazines, just a couple of months before I went for interview, had done a series of articles on testing large rockets. And as a consequence of that, when I went for the interview, I knew a lot of the answers was the questions they were asking.
Okay.
So I got the job, and the job was writing procedures and helping with the countdown procedures for Blue Streak, which was being converted into a European satellite launch vehicle.
Mm-hmm.
And I worked with them on that, went out to Woomera for the first launch campaign. We also...
What year is this now?
This
to
is,
tell everybody
let me
out
see,
there?
this was 1961 when I joined them.
1961. Wow.
And we used to do a pre-launch test up at a place called Spade Adam in the north of England, which was a place difficult to get to in the winter because it was a lot of snow up there. But we used to fire it up there, do a full firing test, holding it down. And once we were certain we were ready, we would then pack it all up and ship it off to Australia, and then it was launched from Australia.
Boomerang, like you said.
Yeah,
Woomera,
Woomera, yeah. Uh,
We've got listeners in Australia. Scott Polk is in Tasmania
oh, right.
down there. And we got Cliff Watson is watching from Pomona area up
Oh,
there.
right.
And yeah, we got people all over the world that are enjoying this.
Well, I worked on the first stage for a while, and then as we were converting it to a satellite launch vehicle, ELDO, who was the European Launcher Organization at the time, brought in the Germans for the third stage, the French for the second, and the Italians were going to provide us with the satellite.
Mm-hmm.
So they needed to coordinate all those trials. And I moved into a group that was doing that. We were managing all the different activities from the different countries and different stages. And at the time, I noticed an advertisement in one of our newspapers for people to work on Apollo.
Mm-hmm.
Now, being a bit of a space nut, I thought this is just what I want. So I applied, and they turned out they were looking for somebody with launch preparation experience. And I got recruited. One of 27 British engineers, because Bendix had got the contract and discovered they didn't really have enough engineers to do the job.
Mm-hmm.
So they recruited 27 of us at the time.
I'll be gone. Well, we're going to talk about some of that and look at one of the other guys that we've had in here. And we wanted to, in just a minute here with Keith Wright, we want everybody to know we're doing Shuttle Fest April 15th, Saturday at the Hyatt Place Hotel, celebrating the documentary The Base to Space, the platform, mobile launch platform number 2 that launched Apollo 11 to the moon and a lot of historic things, and we're going to enjoy a couple panel discussions, and maybe an astronaut or two will be there, but something that our staff is working on here now. You mentioned the Brits that were recruited for the Apollo, and I understand you had lunch today with Mr. John Tribe.
I did.
How's John doing?
He's doing fine. We had a really, really good lunch and reminiscing over old times.
Yeah, good. Yes, and we met this gentleman, Mr. Bruce Smith, was in the museum, and you know Bruce, another Brit that was on the ALSEP program.
He was.
He was involved with the
heat flow experiment.
Yeah, the heat flow experiment on there.
He was designer of the electronics on the heat flow.
And there you are, Bruce. Good to see you. Hope you're doing well with your family back home. Here he is over a year ago when we were doing our broadcasts in our conference room there. And Keith, we're approaching 3 years this week of broadcasting Stay Curious programs. So we're glad to have you aboard. Hello to Bruce again there. We're going to talk about This Is It. This is part of one of the Apollo science experiments that was on the moon. This particular one was Apollo 14.
Yeah.
Apollo 11 was a little bit of a, it was not up the full complement. It was just a few experiments.
That's a very interesting thing. What happened was NASA decided that the first landing was going to be a lot shorter. The EVAs were going to be shorter. They were really just interested in it being more of an engineering proving, getting to the moon. But they did want to do something out on the surface, and Bendix were given the job of coming up with a design which was approved in November 68.
Wow.
And they delivered it in the end of April 69. So they did an amazing job, and there were some a few fudges with the design, but they came up with a D-rated experiment package, which comprised a seismometer and a laser reflector and a dust detector.
Yep. And Bendix is in Ann Arbor, Michigan. They were the later ones. This is the Apollo 11 deployed there. And look at this picture closely, folks, because Keith has got a personal attachment to some objects in this photo that we're going to Stay Curious with. So find out what Keith Wright may have left on the moon that might be in this picture here. The instruments were to run autonomously after the astronauts left and make long-term studies of the lunar environment. Here's Buzz at the Eagle. This is where the Lunar Module Scientific Equipment Bay. This is my way of saying hello to Marty Winkle, who's been with me these 3 years, Keith, on doing Stay Curious. He, of course, was a lunar module engineer with Grumman, working on the electrical engineer.
Yeah, in fact, I thought his face was familiar.
Did you?
Yeah.
Really?
Yeah.
Well, Marty, this is what, quad 4?
3.
Oh, that'd be quad 3 in the back there, where it's at. You're looking at the back side of the lunar module, 23 feet tall. Like I tell our guests, we have a big mural of this that Grumman has loaned us for years. And I say it's like a 2-story apartment complex, but the only room you can use, Keith, is the bathroom.
Yeah.
All right, upstairs, indeed. Am I right, Marty?
Yeah.
That's about what it was like.
It's pretty close.
Yeah, for a 2-story
Maybe a walk-in closet.
Yeah, and so, and these are the experiments. Each of the successful 6 lunar landings. There's the checklist of some had the same, some didn't, and the experiments had a central station, and we're going to see that supplied power generated by a radioisotope thermoelectric generator called an RTG, and thermal control was achieved by passive elements on other experiments to dissipate heat and so forth. And we have one of those here. Hold that up.
Well, this was actually for Apollo 11. Apollo 11 was solar panel powered.
Right. And that's what's deployed there in our.
And we were trying to get it to survive through the 2 weeks of lunar night, and we were worried about the electronics getting too cold. So these were two of these were provided. They contained a small amount of plutonium, and they produced 45 watts of thermal energy.
Okay.
And they were mounted on the top of the
Yeah,
electronics.
we have this in our display here
Yeah.
at the museum, is what we're talking about here. And we'll, you barely get a hint of them on the tray that Buzz is in front of there. Radioactive decay of plutonium-238 in thermocouples to generate approximately 70 watts of power. Not in this, but
that
on
was the RTG.
That was the RTG
Yeah.
that we're going to be talking about here.
Yeah.
So.
Well, being English, I got all the hazardous operations with ALSEP.
Oh, did you?
I got the radioactive systems. I got the pyrotechnics, the explosives. So and the activities at T-minus 14 hours on the 525
And
level.
we'll see a few pictures of that
Yeah.
on there. We have a question, Marty.
Here we have a question from Dave Stangy. Keith, did you attend the presentation that Harrison Schmidt gave at Macomb Community College many years ago? That college is located in Michigan.
Did I?
Harrison Schmidt in Michigan. Were you ever in Michigan to see a Schmidt presentation?
No, I wasn't.
Okay,
No,
Macomb.
I met Schmidt, which
17.
No, I didn't. I met him before when he was shadowing a mission. I think it could have been 12.
Okay.
He was there with at the crew compartment fit and function.
Now, he'd have been a
that's
true geologist back then,
Yeah.
training them,
Yeah,
because
yeah,
of course he was chosen at the last minute.
Yeah, I
not
think he
last
was
minute,
training the crew at that
yeah,
time,
right.
and gave us an explanation. He showed us this piece of equipment, which I don't know whether you'll have a photograph of it, but
We might, but
Anyway,
Keith
what
came
it
in
wa-
yesterday and gave me a big bunch of pictures, and we loaded them up. What I wanted to mention here, Keith, was
Yeah.
all of these experiments ran on the moon until September 30th, 1977. Now, the first experiment, as you see, Apollo 11 had 5 experiments there, and that was in July 69, and then Apollo 17's in December 72.
Yeah.
So you got a decade of good information till 1977. Well, not a decade, really. I guess 8 good years. And then they turned off all the ALSEPs
they did.
because money. They were working,
Yeah, they were working.
but it was
yeah.
the fiscal year in America goes from October to September 30th. So September 30th, 1977, they flipped off the switch because they didn't have money for them in the
They were
78 fiscal
they were
year.
working at a reduced rate because the power level from the RTGs had dropped, so they couldn't do everything at once, which is so it was a bit degrading.
So it's 44
But-
years. It's 44 years that
But
were
I'll tell
been
you
analyzed
something:
this data.
the laser reflectors we put up are still there, and
Absolutely.
still working.
You can tell us about that in a minute as we're looking here at astronauts. What are we looking at here? And this little thing is on the bottom of on there. You might be able to see the knobs for that on the bottom. But what are we looking at here?
You're looking. That's at Johnson Space Center,
Johnson, okay.
That's when the crew were doing a deployment with the training hardware.
And I always am amazed. It's just like a warehouse or a room you'll see where they just set the experiment up. They did some outside training you'll see here. But then the engineers and photographers and people just milling around watching, right?
Yeah. So they were those were all designed to simulate the 1/8 weight of the experiment.
Gotcha. 1/6.
1/6 weight.
Yeah.
Sorry, yeah.
There's the little RTGs. that
There's
we
2
have
of them mounted on the top.
on that, and that's what was taken. But Buzz Aldrin carried out to a station there. So what are we looking at here?
This is the laser reflector. This is the receiving inspection of the laser reflector. As
Please point out when you're in there, my friend, because
yeah, I'm not in this
you're
one.
50 years younger at least in these pictures.
Yeah,
And I know you don't feel it, but it's amazing, isn't it?
it is. That's the laser reflector in the SEQ bay on the lunar module just after it was installed.
Now I'm going to ask Marty if you remember any of this installing these in the quad there, Marty. That I don't think that was your
done
duties.
on the interesting thing about this was it was delivered so late that we had to install it on the pad.
On the pad.
which was not what we intended with ALSEP.
Inside the slaw.
Yeah, so what we had to
The
do, we only
space-
had a small team, 7 guys, 7
Huh.
people. And we had a couple of technicians and a couple of engineers. I was one of the engineers. And we had to carry the stuff up the
we'll see
launch
that in a
umbilical tower, across the swing arm.
There we go. We just see a picture of that. Just a second.
Yeah.
Marty, what do you remember about any of this stowing of these Alceps?
Absolutely nothing.
Oh, okay.
I was not involved at all.
All right. He was up in the ascent stage, checking the switches were
Ah,
working
right.
right and all that stuff. And there it is on the moon.
That's
14, I believe.
yeah, that's
And what
that's
what I
14. We put them out on 14, this, and was
11,
it 15 or
14, 15, and
15, I think
17
it was.
maybe. You watch the Big Bang Theory sitcom?
No, I don't.
Oh, okay. Well, they do. It's a situation comedy, and
Yeah.
they're jet propulsion laboratory nerds, and it's very popular. The Big Bang Theory. Ain't
Oh.
made it to Britain.
I don't think so. There is a Big Bang Theory, but it's a comedy.
Well,
No, nothing to do
anyway,
with
they
space.
one of the segments is they hit one of these with a laser off the roof of their apartment complex in Pasadena, and it comes back. And the purpose of this is to tell the distance, exact distance from the Earth to the Moon, and the Moon is moving away at about an inch a year
Yeah,
away from
yeah.
the
And
so,
it also, you can see the effect of planets like Jupiter on the orbit of the moon as well.
Absolutely.
Yes, it's
There's
so
a lot
accurate.
of very static and simple. It's just a bunch of prisms that they bounce lasers off of. All right, here's the core.
Yeah, that's an ALSEP. That's Apollo 12. That one.
Okay. That's
Oh, sorry, no, I'm wrong. That's the PSEP.
Yeah, that's
With
the,
the brackets we
PSEP
threw
Apollo
away.
11, actually,
Yeah.
it says here, arrival.
Yep, that's correct.
And there's the PSEP arrival, power to the ALSEP. And we love looking at these pictures, Keith, that you brought, because we're seeing some astronauts
Yeah,
there.
you are. You've got
And there's
Buzz
Buzz
Aldrin.
Aldrin in the middle and
Yeah.
John Young on the right.
the guy with his back to you is Don Lind, who flew on the shuttle later on. He was the
John Glenn was there, huh?
Don Lind, yeah, what he was doing was he was shadowing the design of all the ALSEP and putting in the astronauts' inputs,
Oh,
so that there was quite an influence from the astronauts as to how to deploy, what labels they needed to give them clues, which things to do next. And
well, there's the mighty Saturn V rocket with the launch umbilical tower and the service structure there. And this is up on that service structure.
that's the PSEP in the SEQ bay.
And you had to go up like Marty did. Marty was in that slaw, the spacecraft launch adapter.
Yeah.
And
Yeah,
there
that's-
you are. You're actually,
I'm taking the laser reflector
Marty,
across.
he's in the middle
With that-
there. If you circle those chaps about
I'm the
middle.
guy in the white suit.
Looks like you have a casket in your hand.
Yeah.
It's like,
Well, the other guy, it's the one time I've
There
ever
you
seen
are,
a
Keith.
NASA inspector actually handling hardware.
oh, really?
Yeah, the two of us, we were so short of people. He was helping me take it across, and we passed it to the technicians inside, and then they did the installation.
Marty, you walked across that a few times, I'd say.
Yeah,
How high up is that?
that's the
Beyond 300 feet,
200
right?
280 foot,
320
isn't it?
foot, then you're on top of the MLP and on top of the pad itself. So we're probably closer to 450, 500 foot.
Yeah, with a transparent
And how are you
floor.
with height, Keith?
No problem.
No problem?
No problem.
Oh, my knees would be knocking. You'd see my handprints in the rails as I crawl along there. Well, more astronauts looking at the, what is that with the
That's
veins
12.
on it? Okay.
That's the sub package 2 with the generator on it, the RTG.
That's the nuclear generator
Yeah.
there.
They're going through again, this is a C squared, F squared for Apollo 12 with Buzz Aldrin and
When you say C squared, S squared, explain C.
crew compartment fit and function. It's a thing they did with the spacecraft, and they did it with anything they had to interface.
Okay.
They worked with training hardware in Houston, but they needed to get hands-on with the real stuff before they actually went to the moon.
Now there's Al Bean and looks like John Young, I think.
That's
Is
Pete
that
Conrad. It's Pete Conrad.
Nose doesn't look big enough for Pete. But, and they're wearing, of course, protection gloves. And,
Yeah, because we're in the clean room, and then they took it to the moon and covered it with dust.
yeah, right. There's Pete.
There's Pete. That's with the superthermal ion detector experiment.
And look at the wire antenna or something just on the carpet on the ground there.
That's a ground plane, which was to control static for on the moon.
And you just set these up wherever. And
Yeah,
hey,
well, there was a plan which way they should do it. Oh, this is the thing I was going to tell you about. These are all the hand tools that we on the early experiments. We carried these as well, and on here is a magnifying glass for the geology.
Really?
Yeah, and that's where I met Schmidt, and we were talking about this, and he got it up, and he said, "You know what? This is a very special tool." He says, "See this brush here?" And we said, "Yeah." He says, "Well, do you know what the first thing a geologist does when he picks up a piece of rock? He goes." He says, "Try doing that in a spacesuit." He says, "We have a brush to brush off the dust off the rock."
Cool, huh? I've met Harrison Schmidt a couple of times. I wish I would. Next time I see him, I'm going to ask him if he took his Geology 101 hammer with him.
Ah,
The first hammer that he uses as a geologist to the moon, because that's an important tool to them there. So look at the clipboards, and everybody's checking this newfangled thing that's going to go to the moon. And
here what we're going through is a rehearsal of the deployment of the container for the fuel source for the RTG. This was mounted on the outside of the lunar module, and it actually was a re-entry body in case we had an accident, which in fact we needed on Apollo 13. So what we had to do was devise a mechanism so that they could extract this hot, really hot, half a critical mass of plutonium. So we had to devise a mechanism for them to do that. And what they're doing here is going through the exercise of actually going through a deployment.
And we're going to see several pictures of that in
that's
rehearsal in the
Albin.
moon. A couple
That's
of,
Albin doing
but
it.
it's the bars you see there is the RTG,
Yeah,
the
the white bit at the
radioactive.
top is to keep if the astronaut fell forward, to keep him off the hot capsule.
Because it does have some heat to it. then.
1500 degrees.
Wow, that would be and on the moon 200 degrees on there.
Yeah, and there's someone drew a cartoon of it falling on the floor instead of it doing what it should, and Albin signed it and said, "Draw it like it is."
Okay, he didn't make that sketch.
No,
Al
he
didn't?
didn't.
He's a better artist than that.
Oh, he
but-
is. He's a very
Yeah,
good.
yeah.
He's
I
a
was
very
wondering
good
if that
artist.
was like one of his crude sketches, but that's definitely Al Bean's signature. You own that, right?
Yeah.
That's a nice little piece of memorabilia to own. Now there's the
This is Apollo 12's ALSEP installation in the O&C building, in the
Okay.
operations and checkout building.
and you see the lunar module there in the back there, and scaffolding to it. There you are,
That's it's going through. Yeah,
putting it in the descent stage.
yeah, a lot easier than doing it out on the pad. Those are the closeout pictures.
Mm-hmm. And now that's the bottom side of bottom quadrant of the lunar module, and then
Yeah.
it gets covered up, Marty, not with a panel. That just gets covered up with that
It has
gold
a door.
mylar.
It has a door which drops down.
It does
which
have
has
a door?
Mylar and thin ink canal sheet.
Yeah, ink canal. All right. We're going the wrong way, Peach Fuzz. I've never seen this picture.
It's a really interesting one because Pete Conrad was told to land as near as he could to the Surveyor spacecraft, which had been...
That's Surveyor Crater, and he's
Yeah,
right on the edge of it.
if you look in the far side of that picture, you can just vaguely see a white patch. That is the Surveyor, and you can see how close Pete got to the crater.
About where that X is in the middle, the resto mark. I see the white there. Is that
There's
what
a
you're
white
talking
close to it. It's
Yeah.
part of ALSEP, but right in the distance on the far side of the
about?
crater.
Yeah, I see
this-
that. Where
yeah.
in the center there.
Yeah,
Very cool. Yeah. That was a very. They called.
I'm there.
yeah.
Yep. Right.
Come
No.
left, come left.
Come left. Center.
That's
Left,
center of
left,
the
more.
crater.
Center of the picture.
Yeah, center of the
Center
picture.
of the picture.
That's in it.
Left. That's not it.
Keep going.
Keep
Keep
going,
going.
keep
Keep going.
going.
Keep going.
That's
Stop.
it.
You've got it there, right?
That's the surveyor
Yeah.
right there. It's inside the crater. There, yep. And they were thrilled when they saw that. And that very unusual picture there. Never seen that one.
This is 16 C squared F squared with John Young.
There he is. And that's
the seismometer he's working with.
again, you set up a room, you square off
Yeah.
a safety
Clean
area
room,
there
yeah.
that's clean, and then you have the guys play with these experiments. That's the heat flow experiment there
Yeah.
that John tripped over.
Yeah, unfortunately.
Yeah. There's
This is
Gordo,
13.
I
That's Fred Hayes.
Fred Hayes, yeah.
He's practicing
Fredo.
removing the top cap from the fuel cask. The fuel
Jim Lovell's
container.
in the background.
Yeah.
Jim Lovell just turned 90. Jim Lovell will be 95 years old
Oh.
next week, I believe. Yeah.
They were they were really, it was such a shame they didn't land because they were such a really orientated for the science.
Were they?
Yeah.
And you said Apollo 12, Conrad and Bean
They were
good
good
to
as
work
well.
with, too.
Yeah. But
What was the interest of the astronauts in the science? Was it
It-
oh, we got to learn because these are test pilots
yeah,
now.
it was not that much on 11, but far more with 12. And these guys were really hot on it, Apollo 13. And 16 and 17 were as well. 14, not so much.
Uh-huh. There's the
That's the deployment. That's what he was rehearsing.
right. And then they took him out in the backyard of the KFC facility,
Yeah,
right?
that's right. And they went through and did the training again. That's training hardware, not flight hardware.
Okay.
And in fact, when I was out there one time, they were doing this, and I've forgotten who it was. One of them said, "Well, the solar wind's blowing a lot today because it was
Oh, really?
blowing all the thermal blanket on the central station."
Uh-huh. Were these actually functioning ones or just dummy
No,
weights and
dummies.
sizes?
They were all mechanically functioning, but not electrical.
Okay. Not electrical, not transmitting data, but
No, no.
mechanically
Yeah.
things that
So
had to
they could-
move
yeah.
would move. Another very unusual photograph I'm sharing with our Stay Curious watchers here. The Apollo 15 crew there, Jim Irwin and to the left, and Al Warden, we've
Yeah.
lost them, and Dave Scott's 90 years old on the right.
Yeah.
All the hardware out there.
Yeah.
Never seen this picture before.
I
that
hadn't
crew.
seen that.
Pretty cool picture there.
Yeah. There's another one. He's pulling up the magnetometer. He's removing the magnetometer.
And you got a guy
We
out
had
there.
a very interesting. All these things were bolted down. I should have brought it. There was a very special bolt which was devised because you can't undo, with no spacesuits, you cannot undo an ordinary bolt
Right.
very easily. So what was devised? It was by a guy named Boyd over in California. It's called a Boyd bolt. And you could lock it up, torque it down with a nut on the top. But all you had to do, we had a special tool that went in the top, pushed a pin down, which released two balls. You only had to turn it 90 degrees and it released.
Yeah.
And it would do that under torque. And
Interesting.
there must have been about 50 of those they had to undo on the moon. So it was really quick to go round. 4 for each experiment, then a whole load round the top for the heat shield above the electronics, which they had to pull up.
All that for the launch and
Yeah,
and
it had
keep
to
everything-
survive the launch, but it
Yes.
had to be easy to release, and it was very clever.
and they called the Boyd
A Boyd bolt.
Boyd bolt.
B-O-Y-D.
Boyd bolt. Well, here's a couple other pictures of them training out there in the
That's the drill.
the drill that they, look at all of. I'll bet there's not a power tool sold today that has an electrical cord on it.
Right, it was not
They
many.
all have
Yeah.
rechargeable NiCad batteries.
Yeah.
For
This-
the good
the
ones.
batteries on
and it
here-
pioneered right there 50
Yeah.
years ago.
That was a Black & Decker drill, but it had a very, very special battery.
Right.
The battery was so active that it only had about 15 days of life before the plates disintegrated. So we had to have a series of them in case of launch delay.
Right.
And we had to have access to be able to change out the battery if we needed to pull the drill out, change the battery and put it in.
Wow, just
And
something
that
to
was
think
another
about
one.
if the launch is delayed. Hey, those batteries we're going to use to drill
Yeah,
core samples into
yeah,
the moon need to be swapped out.
yeah.
Wow.
That's why we had at least, well, we had enough, had 5 days spare, so we
Uh-huh.
could.
Another experiment going
Yeah.
on out there. I love the people in the background.
Yeah,
And they act
everybody,
like
they,
they're
they
on.
were monitored. Everybody was making notes, and because if the astronauts were passing comments, hey, I'd like this a bit different, or
Here's John Young. He's got a moon glove on there to
yeah,
try doing something. On Apollo 16. Love these behind the scene pictures
Yeah.
there. Again, there's the
that's the seismometer.
earthquake, moonquakes
yeah.
detector there.
That's
And there's some of it displayed on the moon.
Yeah, it's the magnetometer. Very, very sensitive magnetometer.
The magnetic fields, important
Yeah.
to understand them on the moon.
Yeah, it was quite interesting because we weren't only looking at the moon. What we were looking at was the moon was going around the Earth and it was going in and out of the Earth's magnetic field. So we were able to look at what happened as you transit from the Earth's magnetic field out into open space to see how different it was. And
There
we
you
were
go.
looking at solar wind. We were looking at the magnetic fields, what was happening. There was a whole series of experiments. So it wasn't just the moon; it was the Earth, Moon, Sun environment that we were looking at.
Now you're in the middle there.
Oh
What
yes,
are you
this
looking
is
at?
well. What we've done here is and this took a lot of persuading of KSC safety. We wanted on Apollo 14. We had some problems with this thumper for the active seismic experiment. What we had was this device where the astronauts would fire off Apollo standard initiators one at a time to make small seismic shocks.
Right. Yes.
Well, they weren't.
Thumper.
A
The
thumper.
thumper.
It was a thumper, and we had a few problems with them firing them. And what it turned out was they weren't holding the thing right. It was designed to be held by one hand. You select the firing one you wanted. There were 21. And then you turned the handle here, held it over and pushed it in. You held it over to charge the capacitor, push it in, it fires. Well, what the crew were doing was holding the top knob and then doing this, and it was moving out of detent, so it wasn't connected. So they weren't all firing. So we had to train the crew, and we just trained John Young and Charlie Duke how to do it. We'd fired 2 of these initiators off in the clean room and getting permission to do that was, you see all the black plastic, that's to make sure no static or anything. And we're examining the thumper now just to make sure it's okay after the firing, because we'd never stowed the thumper after firing it. So we had to make sure. That's the engineer in charge of the experiment.
There you are again.
That's at T-minus 14 hours on the 525 level. That's for countdown. That was a countdown demonstration test on 12. And we
So the wall is the wall
it's
of
the
the
slaw.
slaw.
Yeah, and the lunar module on the right.
Wow.
And that's the cask. We just put the capsule in. We'd gone through the whole thing in live capsule, everything. That's again. We're back on the installation of Alsep. I'm leading the.
There you are in the middle.
I'm
Telling
there in
a
the
joke,
middle.
it looks like.
Yeah, I'm having a joke with Pete Conrad and Alvin.
That's fun. Again,
There
run
we
the
are. We're restowing
RTZ.
it. We did a second run. We were restowing it there.
There you
That's
are. Back
for the
up.
launch. That you notice they've now got the Inconel over the
Oh, right.
over,
on
over
the
the
right.
Minot.
Yeah.
See the difference?
Yeah. There's the difference from there. I go back a couple here when you're up
To
there.
there, yeah.
Ah, so that's the lunar module on the right, Marty, there with the Mylar, and then they put Inconel over
Because you've got one of the RCS engines right above you.
it. Uh-huh. Tight space up there, huh?
Yeah, very tight.
Swaying around. What was your
Well,
experience
it
up there?
didn't move much. What happened on one of our earlier countdown? It must have been 12's countdown demonstration test. We'd done that, and my boss and his NASA counterpart came up to have a look to see what it looked like once we'd completed. And I was on the headset, and I heard people in the control room say, stand by on the vehicle, we're doing an autopilot test on the second stage. And before I could tell them, they did it, and the vehicle shook. I looked around and they'd gone. Well, apparently they came out across the swing arm going like crazy because I hadn't been able to tell them what was happening.
That's funny. There again, the deployment there, a couple pictures out of whack here.
We're doing a leak test on the RTG to make sure that the gas inside had not leaked out. There was no chance of any leakage from it.
I love a Polaroid picture there. John Young in the foreground. And...
No, it's not. That's the engineer who designed the. On Apollo.
Like John.
Yeah, on Apollo 15, we changed from putting the experiments in the O&C. They cut a hole in the side of the slaw for us, a panel that could be removed. And this guy in the yellow shirt would design some ground support equipment that allowed us to slide the experiments into the lunar module from the mobile service structure. And this was the first time we did it. So he came down to see how his equipment was working. And that's me on the far side next to the guy in the white suit who's the guy who's our inspector. That's me there. in the grey old brownish shirt.
On the left side there.
Yeah.
Why would they want to not? Why would they want to? I mean, that's a lot of hoisting sensitive equipment and so forth.
It allowed us to do changes to the experiments later.
Okay, they were that
learning from the previous
time-wise
mission. Yeah, so it relaxed our time to get everything ready. Now that's the training. That's where we're firing the thumper.
Okay.
That's John Young. I'm on the thumper. I'm showing them what to do. John Young next to me and Charlie Duke in the orange suit.
The thumper being an electrical charge exerted down in the ground.
It's electrical charge to fire. That's a standard initiator, which is like a cartridge.
Right.
It generates gas above a plate, and the plate thumps the ground.
And the data is
collected by geophones, which the astronauts have let out.
Right. So they're analyzing the inside of the moon.
Yeah, they're doing the first.
And that's what you do with any celestial bodies. You want to know what's going on inside. Yeah. Then you can feel like how learn more about.
Yeah. Once the astronauts had come back, we had 4 rocket grenades, which were launched. Which put out much bigger charges, bigger shocks, and we were able to go deeper. Right? Yeah. That's Charlie Duke. We're going through again the rehearsal to remove the capsule from the fuel cask. That's the tool he used. Now we've done a fit check of the capsule into the RTG, so we went through everything they had to do on the moon.
But he's not doing it with moon gloves.
Not in this case, no. Yeah. It's a fairly easy thing.
And they several sessions of this, not just one time?
No, they just did it one time.
Oh, really?
Yeah. That's me kneeling down, and our inspector, Fred Rapogel.
That's cool. A good picture of you there.
And that's putting the experiments into the container, or getting it out of the container, ready for Apollo 12. That's me kneeling down at the front. Engineers and there were only 7 of us. We were doing hands-on as well as writing the procedures and doing engineering changes. That was a great thing about it. That's how it was delivered from Ann Arbor. I think that's Apollo 11's.
Okay, comes in on a big old plane.
Yeah.
There, all right. And there it is on the moon. There, that's the power source. Yeah. No, that's actually
the central station with the antenna pointing at the Earth. And the flat ribbon cables going out to the experiments.
And these lasted 5 years beyond when the last.
They were designed for a year, and they lasted, some of them, 7 years.
We might be over a mile away from the lunar module there. On this picture is Apollo 16. Is what this is.
Yeah.
And then Apollo 17 to end our program today. A few little pictures of it.
We had a lot of changes. They had a lot of new experiments on 16. But the seismic experiment we did was different. Instead of having rocket grenades, they had little charges which the astronauts put out and had an antenna. And they would start a timer and then leave it And then these timers ran out after the crew had come back. But so in turn, all the different charges they put out, and we would fire them from. It was fired from Houston.
Oh, really? They could
Yeah.
fire them from
Yeah, they controlled.
240,000 miles
Yes,
away.
that was the whole plan.
After the astronauts left.
Yes.
Because they didn't want those
No,
charges
no.
to...
That was the same with the rocket grenades. They were fired from.
And how successful were these experiments?
Very successful. We learned a heck of a lot about the moon. In fact, I do a talk, and you can see the interesting thing is we learned a lot, and it was learned fairly quickly about the structure of the moon. But then about, I think it was 2011, they published a new set of results. They'd refined what they got, and they'd learned more from the laser reflectors, because you can tell a lot about the moon's interior from how the moon moves, how it
wobbles, yes.
yeah.
It rocks back and forth,
And
actually.
they've refined
Liberation,
it, so they
they
were
call
still using data back in 2011 from the
Awesome.
experiments.
Well, we can see the Apollo landing sites from orbit. The Lunar Reconnaissance Orbiter for years has brought back pictures of the landing platforms, the descent stage there in the center. That's Challengers of Apollo 17. The far left, you see ALCEP. Those are your equipment packages sitting there.
That's right.
Still not working. They probably could if we wanted to.
If we could change the generator, they could.
Yeah, being part of the British Interplanetary Society, which is the first and oldest group of space geeks ever founded, I do believe.
1933.
1933.
And in
Arthur
1930
Clarke was involved with
Yeah,
that.
he was.
And Sir Patrick Moore.
Yeah.
And I've
was a
had
friend of
every
mine, yeah.
Patrick Moore book. He was the great popularizer.
Oh, he was a brilliant popularizer.
And while we're talking about pop history here with a Brit, I know you'll love me pointing out that the longest running television program in the history of the Earth is
The Sky at Night,
The Sky at Night.
which was started by Patrick Moore.
Yes.
And
still in
it's still going.
1953 or something.
Yeah, it was. Yeah,
Yeah.
it's. I was 13 then,
Yeah.
and it got me very interested in astronomy.
I've watched it. I like getting the British monthly magazine, Sky at Night.
I
you
get
can
that,
sometimes
yeah.
find that.
Yeah.
And they would have a compact disc in there with programs on it.
Yes, that's right.
And a good fan of the program is the rock guitarist for Queen, Brian May.
Oh,
He's
yes.
a doctor of astronomy. Have you ever met Brian?
I haven't, although I apparently appeared on a TV program just after him.
Oh, okay.
But mine was a recording, and he was live.
He's a Brian May, a guitarist for Queen, is a
Yeah.
doctor of astronomy, particularly asteroids, and he helped found Asteroid Day, June 30th, on there. But we digress from our wonderful guest here, Keith Wright. Sure glad that you came in, Keith. You know, I've seen over the years a lot of little certificates that are given out to people like you and Marty for doing a job well done. Basically, here's one of those Apollo Achievement Awards. Thomas Paine, the administrator, autographed that. A lot of people got this
Kurt
certificate.
Divas, that one, I think.
Yeah, from with your name there. I mean, these awards. Looking back at them a half a century later,
Yeah.
there's an important another letter from Kurt Divas thanking you in August for helping us go to the moon, and then you got the Snoopy Award.
I did, from Pete Conrad.
That's impressive. Snoopy Award is basically an outstanding award of merit for something that you did to save money or facilitate a mission.
I had a little influence on the design of the mechanism to deploy the fuel cask. They were having trouble getting it through vibration. It kept popping.
Okay. The
yeah.
important plutonium cask.
Yeah, and we didn't want that to happen on the way to the moon.
No, you
So
1100 degrees hot.
I was talking about. They came down to KSC, and some of our engineers, including our project manager, and we were talking about this problem. And I just said, well, what we really need is a bolt, and that we can cut. And they devised a system where they had a cam, an arm and a cam, and a bolt under tension, a really thin section, and a little guillotine that cut it. And that's what they did, and it worked.
Well, we hope one other little piece of all three astronauts of Apollo 13 signing this. That's pretty cool. It looks like they're real signatures, different ink pads
It
and
is, yeah.
stuff.
And that's a little pin that they claim they took with them around the moon. That's showing an astronaut carrying Elsa.
I have never seen that pen in this or a letter from these three astronauts. That's pretty substantial there. Piece of history there. Make sure your family knows you have
Yes,
that.
I have.
Marjorie Wade's been watching today. Dave Stangy's enjoying this. Doug Forrest is in Los Angeles. Tom Usiak is waiting for spring to happen in Pennsylvania. Steve Hammer's enjoying our program. Carlton Bailey's our good photography friend. Hey, CB. Hazel Banks was an astronaut secretary to these Apollo astronauts in that era.
Wow.
And she's familiar with the British space geeks over there. She travels there some. Good to see you, Hazel. Jan Shade Beach is watching. Keith Sewell is at Oregon. Hey, Keith. Thanks for keeping up with us. Bill Whiting's back in town. Good to see Bill. Howard Pepper is watching this. And in Dundee, Scotland, Robert Law said he particularly was looking forward to seeing your presentation today, Keith Wright. And Paul Hickson, glad that you're joining us today on Stay Curious. Well, to end the program, you got one little cool story to tell, and you got this cool autograph. Neil and Buzz and Don Lind, who waited the longest of anyone to fly in space.
Yes, he did.
He was a Apollo astronaut who I think was fell into disfavor a little bit
Did he?
by the powers that be, like George Abbey. He eventually flew a shuttle mission.
A space lab.
But Neil and Buzz, what strong signatures there.
Yeah, that's
Lind,
that was signed on the Sea of Tranquility. It was a map of the
A
moon.
few $1,000s there, buddy, for that in there. But as we talked earlier, you had an opportunity to make your mark on the moon. And in this photograph here,
There were two brackets out on the dust there, which were holding the solar panels locked up. And they're thrown away and they're not used, of course. And what happened as we were stowing the experiment, after the crew had come along and deployed it in their crew compartment fit and function test, and NASA principal engineer Hans Rudolph said, "Hey, these brackets are going to get thrown away." And they're thermally coated on the front, but on the back they were aluminized. He said, "Why don't we sign the back?" So the crew, the seven of us, all signed the back of this, and I signed it, wrote UK, and then I thought I'll draw a little Union flag.
did you really?
Yeah. So that got to the moon, and we made it legal. What we did, we wrote a non-conformance report that this bracket had been contaminated and it hadn't ballpen ink on it. So we dispositioned the non-conformance report, clean it with isopropyl alcohol, inspect it, and that's what we did. And we could still see the scratches from our signatures in the.
And there they are, one's
And there
above
they
your
are on the
head
moon.
and one's above my head, ironically. That are the two brackets, and the
Yeah.
gold bracket above your head there, Keith, has your signature on it, the
Yeah,
Union
and
Jack.
Not only me.
Yeah.
I put the Union flag on because of the 27 British engineers who'd worked on the program.
Awesome. Well, Marty Winkle has his name on the very same piece of soil up there at Tranquility Base as the Grummies all signed up a piece of...
Everybody did things.
Yeah, I'm sure there's lots of... So here we have on Stay Curious, two people I'm surrounded by have their name on the moon on Tranquility Base. How cool is that? Can't make that up, folks. Marty, what do you think about that?
About our name on the moon?
Yeah, I mean, yeah, I'm the only one that doesn't have my name on the moon here in the room.
That's the only ones we know of.
that we know of, exactly. Well, that's pretty cool. Keith, you've added a wonderful little twist to our Stay Curious programming this month. We appreciate you being here. Looking back 50 years, a half a century.
Yeah.
I'm a baby boomer. You don't like to think like that, But what do you think about your involvement? You look up at that big old moon shining in the sky. Does it impact you that you had something to do with man's conquest of it?
Yes, it does, particularly because I was a space nut anyway. Before, when I was a kid, comics, space comics, I used to read, and being involved in Apollo was like like dying and going to heaven, really. Being here and being involved was just something I could never have imagined when I was a kid.
Well, that's good. What and to look at the future, Artemis. What do you believe?
Oh, I'm glad we're finally going back, and we need to learn to live further away from the Earth before we even try to get to Mars, because it's fairly easy to get reasonably easy to get somebody back from the space station quickly. But if you're in trouble out there on the moon, you're going to have to be a lot more self-supporting.
Well, I'm just thinking about all the little things that Keith shared with us about the battery life of some of the the drills and so forth that would have to be swapped out maybe if there was a delayed launch and all that. And of course, that's 50-year-old technology back then. But there's so much complexities that the normal person can't even think through. Am I correct?
Yes, you are. That's one reason it's so expensive.
Yeah, right. Because everything needs a backup too.
Yeah.
So, well, Keith, I thoroughly enjoyed this. Just met you 24 hours ago or so, and what do you think of our humble little museum here?
I love it. I think it's great. It's wonderful what you've got here. All the stuff you've managed to collect.
Mm-hmm. Is there something that you'd like to share with our Stay Curious watchers out there that they haven't asked you, Keith, as we
About
bid everyone to do?
Oh, there was one little incident that happened on Apollo 14. We were loading the capsule. And what they did, the capsule was actually handled initially by the Atomic Energy Commission. They had a couple of guys, and they put the capsule on a trough, which was pushed through a small porthole in the side of the slaw, and then a guy on the inside picked it up with the handling tool. We'd prepared the cask by removing the top, ready for the capsule to go in. Well, they just got it inside, and all the lights went out.
Really?
Yeah. So
Up
he was
on
standing,
the whole launch tower there. You just got
just inside the slot.
Oh, okay.
So we were in the dark, apart from the glowing of this capsule. It was gently glowing.
Wow.
And I was on the intercom, and I just gave him my call sign, ABT here. I'd forgotten what the call sign was for the countdown control. I said, we've got a problem on the 525 level. And the whole net went silent because they knew what we were doing. And of course, this was after 13.
Put nuclear power into the side of a moonship, 500 feet in the air.
They said, they asked what the problem was, and classic NASA response, wait one, and about 30 seconds later, the lights came back. Somebody had pulled a plug out on the launch umbilical tower.
Jeez. So completely dark inside
and we just had the glow from the
glow
fuel
from the
capsule.
plutonium inside the casket there. That's a good story. That's a good way to end our program here. We're so nice that you met our museum here, and please stay in touch with us. We've got each other's email, Keith.
Yeah.
Really enjoyed it a lot.
So appreciate thank you for inviting me.
Well, you're very welcome. And we hope that everybody tells their friends that to watch this show here and learn a little bit about our wonderful Apollo era. Of course, I think that the 6 landing dates should be national holidays. The next one's April 20th, Apollo 16 landing on the moon. Certainly, July 20th, they could make a holiday for humanity.
Oh, definitely.
But we're going back to the moon, and hopefully by 2026. But it's going to be a whole different story than it was with people like Keith Wright here, who pioneered with Marty Winkle the Apollo era and our fabulous excursions to man's greatest adventure.
Yeah.
What can you say? So, Marty, we have anything else to clean up on our Streamlabs program today?
No, we don't, Mark.
Well, we have tomorrow Mikey Haddad's in the building. And you know, Mikey is our payloads expert, and he's going to bring 2 other payload experts with him. We're going to talk about the astronomy missions on the shuttle, Astro 1 and 2.
Oh, right.
Astro 2 flew this month in the month of March. And so we're going to talk about looking at the stars from the space shuttle with Mikey Haddad
Yeah, I
tomorrow.
was involved in Space Lab 2 where we had a telescope.
Did you?
Yeah,
Okay,
Yeah.
Space Lab 2, not the German Lab 2?
yeah.
Yeah, okay, D2, all
Yeah.
right. And how'd that work out for you?
We worked all right. We had a few problems. I think was Don Lind on that mission. He might have been.
Yeah.
He was on one of our Space Lab missions.
Well, Keith Wright, you're welcome to come back anytime you're in the States and be again on
Thank
Stay
you.
Curious. We appreciate that a lot. And tell your wife hello and thank you for letting you loose today on there. So, well, like we've got a great program, like I said, together tomorrow with Mikey Haddad talking about the Astro Labs 1 and 2. He has two friends he's bringing in here with him. And Thursday, we'll be celebrating our 3rd anniversary of broadcasting Stay Curious to You, born out of the pandemic. 3 years later, we seem to have found a little niche in providing this type of programming to you on a weekday basis. So, Marty, thank you for a great job, and I thank our wonderful staff here, led by Karan Conklin, for all that they do to make this program a important outreach for the American Space Museum. So until tomorrow, I'm Mark Marquette saying I can't wait to put some stars in your eyes tomorrow and bridge the space between us.